Ja, nu har vi kört en hel del tung Java-programmering här. Men det är dags att lyfta lite grann på näsan och kravla oss upp ur de här 6 fot djupa lagren av abstraktioner i backenden och andas den fria, ombytliga, tunna luften i frontenden. Eller? En gång i tiden så räckte det kanske att i sitt projekt ha en bra frontendutvecklare. Men frontend har blivit allt mer komplext på de senare åren. Och det har också ökat behovet av att ha en frontendarkitekt. Det behovet har växt fram. Frontendarkitekten ska ju då inte bara pyssla med frontarkitekturen för frontenden, utan den har också kommit att bli också lite grann av en brygga mellan utvecklingsteamet och de som pratar om applikation med hur den ser ut och hur den fungerar, som typ produktägare eller andra intressenter inom verksamheten. Nästa talare här ska ge en bild om vad som krävs och vad som en frontendutvecklare kan utsätta sig för i dagens läge. Han själv har jobbat med fronten sedan 2008 och han titulerar sig sedan 2015 som frontendarkitekt. Han har samlat på sig ett antal AWS-certifieringar, bla bla bla. Och sedan 2015 så är han också med och arrangerar React Meeting här i Göteborg. Här för att ge sin bild av 20-talets frontendarkitekt, Stephen White.
Thank you, Christian. Thank you. Hello, everyone. Hi. So, as Christian was saying, I'm going to speak English. I hope it's okay. Yeah, okay, it's okay. So I'm going to be talking about the front-end architect and what it means to be a front-end architect. So, the agenda, background, a little bit of background to why I'm going to be talking about this. Then I want to talk about what is architecture, from a software perspective. What is an architect? Then we'll have a look at front-end reference architecture. Just one, there's many, but we'll just have a look at one. And then we'll just go through a quick summary of what I've been talking about. And hopefully it's made some kind of sense, but we'll find out. Okay, so first of all, background. So as Christian was saying, I've been running the React meetup here in Gothenburg for the last 8 years, and I think I started it as a reaction to Angular because I'd been involved in a number of Angular projects, and I thought, I'm never going to do this again, ever. I need to find people, and I need to find companies that want to do React. So, well, I kind of started the React meetup 8 years ago, and we've had a lot of really interesting talks throughout the years, but especially last year was very, very interesting in my mind because there seemed to be a kind of maturing in the talks. We were no longer just talking about the latest frameworks, the latest libraries, you know, the cool animation bits and bobs and stuff, but people were talking about things like DevOps for Design by Mikkel Vestervori, who's one of the chief architects at Polestar. He's created this thing called Fig Magic, which enables you to be able to export design tokens from your Figma diagrams directly into your front-end build pipelines. And then we had Jack, who spoke about equitable development and understanding the dynamics of front-end engineering and teams. So this was kind of like, you know, how a design system is infected by entropy and how it kind of breaks down over time, and how it's important from a design team perspective and also from a front-end perspective to try and mitigate this entropy and try and uphold the design system so that it can move your application forward for the future. It can be future-proof. So there's been this maturing, and there's been this kind of real craving to reduce complexity. You know, after 8 years of React in Gothenburg, at least, you know, people have kind of built a lot of complexity into their applications. I certainly have. And there seems to be a yearning to kind of reduce this and try and mitigate it. But also, you know, we've been going for 8 years. You know, we've got 1,300 members, and at each meetup we get about 60 to 80 people turning up. So there's this craving for learning. People still want to meet. They still want to discuss what's going on. You know, there's this there's this kind of craving to want to improve. So this has been great. So entropy, Jack talked about entropy quite a lot. So what is entropy? Well, it's a lack of order or predictability. It's the gradual decline into disorder. So I guess all of you have experienced this kind of process in your products, in your projects, or this kind of, what can I say, this disease really in your projects. So first of all, you start off with something that's very ordered. After time, it becomes gradually disordered, and then eventually it just becomes kind of all over the place. So you can an analogy of this is maybe a messy teenager's bedroom. Over time, it just becomes messier and messier, and the energy just kind of dissipates from this bedroom. But if we put a bit of energy into it, we might end up with an IKEA catalogue bedroom, which would be really nice. So there's a way of kind of reducing this kind of entropy, And obviously, if we have a look at cost versus complexity, you could also compare this to entropy. Over time, as the complexity grows, the cost grows. So from a project perspective and from a business owner perspective, they don't like this. You may be delivering features, you may be delivering functionality, but the cost of those features becomes exponential over time. So we want to be able to reduce this. We want to be able to still provide features and still provide functionality, but we want to reduce the complexity and hence reduce the cost. So, as a quick summary of the background, we want to write bug-free, well-functioning software. We want to reduce complexity, reduce costs, but change comes at a cost, and we need to be prepared for entropy. So how do we maintain quality while reducing or minimizing complexity? So before I answer that, let's have a look at what is architecture. Well, it's a set of structuring principles that enable systems to be comprised of a set of simple systems. So they're small composable units of structure, behavior that like communicating with the outside world with interfaces. And these components or these units can be composed into larger systems. So we have structure, and smaller bits of structure can make bigger buildings, bigger units, as it were. But the thing is, from a software perspective, we're not just concerned with structure, we're also concerned with behavior and interfaces. So software is very malleable, it's changeable, it's a kind of tangible thing. And we build these units to solve things like non-functional requirements, but also functional requirements. So things like performance, scalability, portability, compatibility, etc., etc. All of the abilities, basically. So these are the things that we try and solve with these units. So what is an architect? So back in the day, when I used to be a Java developer, and still am, I guess, I read and studied and got the Sun Certified Enterprise Architect for J2EE technology. Is there anyone else in this room who managed to get this certification? Wow, just one person, that's amazing. Okay, it was very useful at the time, and it was a great thing. But anyway, the big thing that stuck out in this book was this statement about what an architect is, which comes from Vitruvius from 25 BC. So, the ideal architect should be a person of letters, a mathematician, familiar with historical studies, a diligent student of philosophy, acquainted with music, not ignorant of medicine, learned in the responses of law, I should say, familiar with astronomy and astronomical calculations. So I guess all of you as architects kind of feel this. No? Okay. I try to personify it. But basically, I mean, it means that an architect is someone who's very, very well-rounded. We need to bring a kind of well-roundedness into our architectural designs and also into the way that we handle teams, for example. So, we have a working knowledge of the business, we have broad knowledge of technology, mature, experienced, educated, etc., etc. We bring all of this into the melting pot of architecture. So, one of the differences between, say, a developer and an architect is that the developer is concerned with what happens when one person presses the button, but the architect is concerned with what happens when, a million people press that button. So that's one of the defining factors, I think, between what a developer and an architect. So let's just have a look at the process quickly and the process in which a software architect kind of lives. Now, traditionally, we would build structure, so we'd build our amazing brutalist architectural designs. We'd send them off into the waterfall and hope that we get this back. But in many occasions, we just get the shrieking shack back. So the thing is that the waterfall process just doesn't really help, when we're dealing with kind of changeable systems, as it were. We need to be able to adapt to these changes. The waterfall process would dictate that the architecture defines what is going to be built, and the developer outlines how you would build this. And this handover of definition to the developers hasn't really worked. And as a result, things like XP, the agile processes, have appeared. So the movement away from the detailed plan to an iterative agile approach leads us away from the traditional concept of the architect and more to a team leader or senior developer or tech lead or something. So an agile approach to software development actively encourages us to start work on solving problems in smaller pieces. It encourages us to begin work before we know the answer to everything. So we have structure, behavior, and interfaces, and we need to kind of move ahead with these things in mind, but incrementally. So what do? Well, we create software architecture, but also we communicate decisions, we provide inspiration, guidance, mitigate risk, and reduce complexity. And we also try and make everyone happy. So one of the things that's made me really happy recently is reading this book. And I don't know if has anyone else read this book? Anyone else inspired? Just one person. Wow, amazing. Okay, I really advise all of you to read this book. This has been a huge inspiration to me recently. And the main giveaway from this is that we want to write better software quickly and not worse software slowly. So, one of the main things is that we think that quality comes from being slow, taking our time. But actually, quality does not come from that at all. It comes from how we view the process of software development. So, David Farley talks about being an expert learner and being experts at managing complexity and having TDD and CI and CD as like a way of being able to monitor this and to be able to feed into this. So we have things like modularity, cohesion, and then we have things like being iterative, adjusting to feedback, incremental, and empirical, and experimental. And it's important to note that both of these kind of feed into each other. There's a balance here, and we need to take care of this. Okay, but complexity. We want to be masters of reducing complexity. So we have accidental complexity, but also we have essential complexity. So the accidental complexity is the complexity that's inherent, just in the computer, if you like. Network communication, APIs, all that kind of stuff. But then essential complexity is the stuff that we are responsible for. The things that the algorithms that we create, the calculations. Maybe just adding an item into a shopping cart, for example. But the thing is that what we want to do is to be able to split these things up. We also one of the main things of accidental complexity is maybe organizations, external partners, for example. The organization may infer its own complexity into the software process. They want you to use a specific framework or something. And we need to try and keep these as separate as possible. Okay, so moving on to reference architecture. keeping an eye on the time here, and I need to drink some water just a minute. Okay, so how does all of this fit into the front end, and how does it all kind of affect what we do in the front end? So we have our reference architecture, and most people think that front-end reference architectures are full of superstar developers, hackers, unicorns, aliens, and people who go on crazy conferences like Nordic.js, where we do laser-guided meditations and we fly around in the cloud. But no, we need to get a grip on this. And architecture in the front end is just as important as it is in the back end. And it's really important to note that the languages aren't important. The important thing is adhering to best practices and adhering to modularity, cohesion, and all the kind of usual things that you would adhere to in back-end software development as well. So if you're doing JavaScript, that's not the important thing. The important thing is best practices. Okay, so if we have a look at the basic reference architecture, always start off with testing. So bring in unit testing right at the beginning. Then we have an API. We need to be able to communicate to our backend in some way, and the API can be modularized. So instead of just writing everything in one file, it's good to be able to separate these concerns and keep them in their own place. Then maybe you have pages. You obviously have pages if you're doing front end, or screens depending if you're on a mobile device. Then you'll have things like theming, maybe common components. If you're using atomic design, you'd have atoms, molecules, and organisms. So this is a gradual increase of components, if you like. Templates, and then all of a sudden you end up with a design system, which is maybe something that maybe you would have started with right from the get-go. And obviously, global state always kicks in here as well. Then we have navigation. We have infrastructure. There's a hell of a lot of infrastructure in front-end applications, especially mobile applications as well. But then also we have the edges, so we have a UX team. We need to be able to communicate with them. And then also we have product owners. We need to be able to communicate with them as well. But we need to be able to tighten all of this up. So we need to be able to tighten up what we do in the front-end architecture, but also tighten up these points of communication. So, obviously we have contracts. We have an API contract to the back end. We have a design system, or we have Figma, for example, as a contract between us in the front end and also the UX team. And then also maybe you have, you definitely have contracts between the product owner in the form of requirements. So it's important to keep all of these in check. But then the thing is, we need to bring in constraints to all of this. So, we have our CI/CD pipelines. Obviously the back end has CI/CD, the front end does. But then also, thinking back to what Mikkel was talking about in the React meetup, we can have CI/CD also in the UX, in the sense that we can export the Figma design tokens directly into the front end, which is really, really super cool. So we can kind of wrap all of this up, and we can automate these kind of processes. Wow, I'm running ahead of time. This is amazing. Okay. Maybe I should slow down. Right, okay. Summary. Okay. So anyway, the role of the architect. The static role of the architect has changed to be very dynamic. Call them a lead developer, call them tech leads, whatever. But they're very much involved in the whole building process. They don't just create, UML diagrams, hand them over, and expect everything to adhere to these particular UML diagrams. They're very much there in the dirt. So gone is the day of the PowerPoint architect, and that's very important to know. Especially within an agile process, it just doesn't work. We're drivers in reducing complexity, learning, so I hope that we can maintain this sense of learning within the teams that we're working in. We're tamers of entropy, we're trying to always calm down the complexity that kind of just feeds into your applications. We're gatekeepers at the edges of the front-end team, so we need to communicate to the back-end team, the UX, and also the product owners. So, we have quite a big sort of role, from a communication perspective, and also external systems, for integrating into those. Empiricists who eat evidence, experimentation, metrics as a basis of architectural decisions. All of this stuff needs to feed back into what we're doing. Communicators, and maybe even stargazers when thinking about Vitruvius. Okay, thank you.